build a machine learning model to predict the presence of diabetes. At first, it sounds like a simple yes or no prediction, but it's actually a little bit more complicated. This is actually a regression problem, which means the model is predicting a number, not a category. In the dataset that we are using today, that number represents a diabetes progression score based on patient health measurements. And today we're coding a decision tree to predict it. So let's break it down. First thing we need to do is import all of the necessary libraries. Today we have NumPy for math, Pandas for data, scikit-learn for our machine learning toolbox, and matplotlib to build a pretty cool visualization later on. Next, we load in this diabetes dataset from scikit-learn, and this is super easy because it's already built into Python. The dataset has two main parts, the features and the target. The input features are all of the details about the patient's health, like their BMI, height, gender, etc. And the target is the diabetes progression score itself that we are striving to predict. It's now time to do one of the classic parts of machine learning model creation and split the dataset into a training set and a testing set. This is one of the biggest ideas in machine learning. The training set is what the model is allowed to see during its training stages and learn from to find patterns in. However, the testing set is kept top secret during the model's training stages. We save it for when the model is finished to test its performance on unseen data so we can gauge how it'll work in the real world. And as per usual, we are going to use 80% of the data for training and the other 20% for testing. Now it's time to actually create our model, which is a decision tree regressor. A decision tree works by asking a series of questions about data and continuously splitting it into smaller groups. For example, it might ask whether a patient's BMI is above or below a certain value and split the data based on that answer. Then within the higher BMI group, it might ask whether the patient is over 40 and split the data again. And then it keeps going and keeps splitting until most of the data points inside each group have a similar target. And remember, since this is a regressor, the final output is a number. You'll also notice that we're setting the max depth to 4, and that's important. Decision trees can overfit very easily, which means they can memorize the coincidences and caveats and noise inside the dataset and perform much worse on new data, which is not good. We obviously want our models to do the best they can in the real world. So limiting the tree depth is a very effective strategy for keeping the tree under control. Once the model is created, we have to actually train it with the fit function. This is where the machine learning actually happens. In decision trees, the learning is the model deciding which questions it needs to ask to split the data most effectively. The tree looks at the data and tries to find the feature splits, which are those questions that split the data that reduce the error as much as possible. And it keeps building that structure until it has a full set of decision rules. At that point, the model has learned a pattern from the data and is ready to make predictions. Then I use the model to predict the output values based on the inputs of the test set. This is that top secret data set from before, but it's not so top secret anymore because we're actually feeding it to the model now. This is where all of the input features, which are the patient's measurements,